Welcome to the introduction to the course Fault Diagnosis and Fault Tolerant Control. My name is Riccardo Ferrari and I'm going to be your main instructor for the next 7 weeks. So let me guide now through an introduction of what we're going to cover during the course and how we're going to structure it. So I will guide you through prerequisites, through a course description, the structure of the course, the dates where we are having lectures, how you're going to be assessed, what are the resources and tools you need, and which are the staff members teaching. First of all, the prerequisite is a knowledge of dynamical systems theory. Have a look at this word cloud, and if you don't understand or don't recognize some of the words there, then it means you need to do some preparation work. And I will provide a list of books and resources you can use. One of the main activities we are going to carry out later in the course is to design a schemes like this one. A feedback control systems with an observer and a state feedback controller. And possibly we are also going to add another kind of observer for detecting faults. But this is something that you need to be able to master. And we're going to implement this kind of approaches using MATLAB and Simulink, which is going to be your workhorse during this course. So have a look here. We have an example of a block diagram for a 3 tanks system. This is a benchmark example we're going to use later in the course. Have a look on the left on the block diagram and try to see if you can understand what's going on. And then look at the right. This is some MATLAB code that is used to initialize parameters that are needed by the blocks on the left. In any case, I present here a list of books mostly covering the use of MATLAB and Simulink for analyzing and designing control systems. So please have a look here in case. And also, it would have been great if you followed one of the courses that you see here, either the Control Theory course on the Control Systems Laboratory or the Integration Project for Systems and Control. But now, a word of motivation. Why do we care? Why should you be following this course? You should, because if systems are not tolerant to faults, catastrophic events can happen. Like this. This is an example from a launch of a rocket a couple of decades ago, actually. This rocket was meant to carry a satellite to orbit, because after a few seconds after the launch, this is what's going to happen. It's blowing. And the reason was a faulty valve providing fuel to the engine. But catastrophic consequences can also happen with structural systems like a bridge or a building if you don't monitor them. Or, this is an example of another aerospace system, a helicopter having an hydraulic failure affecting the rotor in the tail. And as you can see, they are not having an easy time. They're trying to do an emergency landing, which is going to be some way successful. Then, regarding the course, this is going to be a flipped classroom course, which doesn't mean that you are sitting upside down, but that we're going to have first lectures posted online, and you will have a couple of days to watch them, to study them. Then, during classes, in-person classes, we're going to discuss and integrate them. So, over the next 7 weeks, each week you will get 2 sets of pre-recorded video lectures from previous years, and then we are going to have an in-person class for discussing, integrating them, answering some quizzes related to the classes, and then starting to solve together a group assignment. And that's important because at the end of the week you are supposed to finalize that assignment and upload that to Brightspace. And you're going to be graded on this. So that's quite important. You take part to the classes and you work with your group. In total, the workload expected is listed in this table for a total of exactly 4 European credits. The structure of the week is as follows. Except for the first week, because of the holidays that we have, I'm going to post lectures online on Friday. So you have Friday and Monday to watch them. And then on Tuesday we have the first class. At the end of Tuesday I am posting the second set. So you have pretty much other 2 days to watch them. And on Thursday we have the second class. And then you have the rest of Thursday and Friday to finalize and then submit your assignment. The last 3 weeks are devoted to self-study and preparation for the final test, which is going to happen on Thursday, June 24th. And this is an extract of the summary of the calendar. As you can see, we're going to cover 6 main modules, but they are not to occur in the usual order because of the holidays that we have. So we are going to miss a couple of Thursdays, May 5th and May 26th. And so I had to rearrange. But don't worry, even if the second module is coming after the third and the fourth, that's not going to be an issue because the third and the fourth doesn't directly depend on the second module. Regarding assessment, as anticipated, you are assessed on homeworks, the group assignment for 30%. And the final individual written test, which is going to happen in person, is going to account for the remaining 70%. Here is a list of suggested books. Most of them are available also as e-book at the library. But the main one is the first, the book by Blanke, Kinner, Lunz, and Starosiewski and Schroeder. And software and tools we're going to use, as anticipated, is MATLAB and Simulink. You need to master that very well. We're going to use Brightspace for disseminating material for news and for the assignments. And in order to have classes in a hybrid format, in case somebody really can't come, we're going to use Microsoft Teams. But please, this is going to be an in-person course, so come to lecture. Otherwise, you will miss most of the interaction, the exercises, and the ability to work effectively with your group. Apart from myself, there is going to be a second instructor, which is Dr. Alex J. Gallo, which will teach on Thursdays. And remember, please, to join our Microsoft team. Here you have the link. And that was it. For any question, don't hesitate to contact me over email. Thank you and see you in class on Tuesday.